So this whole lesson, 1.4, has to do with min and max of a graph, which you might kind of remember from Algebra 2. I'm going to teach about that next week, but we're going to use our graphing calculator to find some information. So this is really about learning about the graphing calculator. One thing I want to tell you is you can pull information off of some graphs that are nice and neat and pretty like this. So for example, if these first two don't require graphing calculators, if it asks for a min and max, it's like your turning point. So what we're just naming really are turning points, and we'll call them something else next week. But this is like a turning point, and that's a turning point. This is a min, this is a max. They're considered local or relative min and max. You'll see those words written in there, an absolute min or global min and max. Don't worry about the word in front. Just be able to tell me that that is a min and that's a max, meaning it's a lower turning point versus a higher turning point, okay? There's 2 minimums here and 1 max, so we'd have 3 that we were finding. So you can have more than 1 min, more than 1 max, or you could have none, okay? But how do you do that same process when you get something crazy like this? So this is where we're going to learn how to use the graphing calculator to do A and B. We're just going to do A and B today. So we're going to do it in both of these, and I'm going to show you really cool things. Now, the graphing calculator is, it's pretty wonderful, but it's limited. And it's limited by the user also that's doing it. And I couldn't figure out a mistake I made last period. I'll just say it. I'm like, why am I getting the wrong answer? All of them are getting the right answer. I'm getting the wrong answer. And I put something in my calculator. Instead of 0.5, I put 0.05. It changed the whole thing. So one piece of advice is when we're typing them in, do it slowly, double check. You would hate to go through all the work and all these buttons that you have to press to realize you typed it in wrong. Okay? So let's start with A, finding the real zeros. So let's talk about zeros. This is also something I think that comes up in the lesson, or maybe it doesn't. I think they just expect you to remember what zeros are. Does anybody remember? Okay. Zero. It's x-intercepts. It's x-intercepts, or solutions, or roots, or x values. There's lots of different words. So if I asked you to solve this equation, crazy, set it equal to 0 and solve it, factor, I don't know how you do it, but there are ways. But the solutions you get would also be considered the x-intercepts. So the zeros of this graph would be that point, and that point. And you can just pull those off the graph. You can name those points, right? But how do we do it here? And that's where the graphing calculator comes in. So everything I'm about to teach you is on the little tips form I gave you. It should be in the front of your binder. So everything I'm saying out loud, don't think you have to memorize. Eventually, you'll just know how to do it without worrying about it. But the steps are in here. We're going to clear the RAM. I wrote that on there. And then, it says find the minimum and maximum. That's on the back. Find the zeros. Find the zeros of functions. So all the steps are on here for you to reference if you're not in class. But let's clear the RAM first, because the last period has been working with these, and they were changing the window and all kinds of stuff. So to clear your RAM, remember you hit second plus 712. It's on the bottom of your calculator sheet, but I would just learn those steps. Second plus 712. You'll do it all the time. Okay? All right, so let's go to y equals. So y equals, top left, and type this in. All right? So just like you see it, x is right next to the alpha button, 0.25x to the power of 4. Now here's where some calculators are different. Some of your calculators are just like mine, where the cursor is up in the air. If that's the case, you need to hit your right arrow button to bring it back down. Okay? If your cursor wasn't up there, you just keep typing. If the 4 was at the same level as the x, you're fine. It knows that it's an exponent. You just don't have to do that step. And then minus 0.25x to the third, right arrow, minus 2.25x to the second. Get it typed in, and then hit graph. Let's just make sure everybody is here. If you're not, go back and if your graph looks different than mine, you need to go see if you typed it incorrectly. And if you want to change something, you can put your cursor over it, hit delete, and then type something else in. Well, I just typed good.
Oh, that's what I'm not.
Anybody else? Okay, so the zeros are your x-intercepts. It looks like there's 3 of them, okay? And it doesn't matter what order we put them in. I'm just going to go left to right, okay? So how we find them is this. Watch. So above the word trace is calc in blue. That means calculate. Since it's in blue, we're going to hit second. So second, calc, and you get a whole menu. We want the zeros. So you can either arrow to 0 or just hit 2, since there's a 2 next to it. Okay? And you should have on your screen something that says left bound. So this is weird right here. What you want to do is take your cursor that's at 0, 0. You see it blinking? And you want to use your left arrow button. I'm going to go over to this 0 over here. And you just want to move your cursor to the left of the 0. Now, remember, this is a calculator screen. It's not perfect, and we could mess with the zoom and change things to really make it really obvious. Because here's what's confusing to people. It looks like we're above the x-intercept. And we are. But we're also to the what? Left. Because as it goes up, it's going to the left. It just doesn't look like it's so much, but it is. So that's really your left bound. So once you get there, and you could be like one more up. I mean, it doesn't have to be perfect. I just try and get pretty close to it, and then I hit enter. So once you're happy with where the cursor is to the left of the x-intercept, which is above and to the left, hit enter. Okay? Then it's going to give you right bound. Right arrow key, move your cursor below, but is also to the right. Right now, my cursor is below, but it's also to the right. Just know it's going like this, right? So it is below it and to the right of it. And hit enter. And I hate that they use the word guess, but that's what they use. And we want it to. Yes, please, tell me what you think that x-intercept is. And you just hit enter again. So we did left bound, enter, right bound, enter, guess, enter. And it's going to give us a 0 at that crazy number. And that's the ordered pair, right? All of our x-intercepts should have a y value of 0. That makes sense. So we have a 0. And let's just go to 2 decimal places for this assignment, because that's what my key is, and I don't want to have to rewrite them all. 2 decimal places. There's a 0. Weird, right? Where the 0 up here was at like -4, nice and pretty. Nice and easy. Okay, but they're not always like that. Okay, there's another one at 0. I think it's at 0. Let's check. So what I always do by accident is I start arrowing, but I'm noticing I don't see that left bound thing. Oh, I forgot to tell it I want it to find a 0. We didn't mess anything up. It's fine. Just go second, calc, 0 again, and see how it gives us that left bound? You want to get your cursor to the left, which is also below in this case, the x-intercept. Hit enter. They want us to go to the right of it. Enter. Guess. Yes, please. Enter. And it's working. When you see that happening in the top right corner, it means it's figuring it out. What's going on? It's confused. For a good reason, it's confused. Whenever your x-intercept is on the x-axis at 0, hey.
How are you guys doing? Okay?
We're good. We are doing fun things on our graphing calculator.
Are you doing all right?
Yeah, no, we're good. Thank you.
Right.
Are you doing okay, Mr. Henderson?
Yeah, you know.
You're fabulous.
You're fabulous. You guys are fabulous. Thanks for being here. We're running, not to jump into math, right? We're running about 40% attendance, so we're at 7.
I know. I told them I'm very proud of them for being here.
Like less than COVID. Yeah, very proud of you guys.
Yeah.
Thank you.
Yeah, thanks so
you
much.
much.
Yeah. So the reason it's doing this is, and I don't know why, maybe I'll Google it and find out for you, but whenever your x-intercept is 0, it won't tell us. But you know what that did? It confirmed for us that there is an x-intercept, a 0 at 0. Why did I go through that? When I look at the graph, enter to quit, when I go back and look at the graph, I think it's 0, but I'm not going to guess. I'm getting weird decimals. It wasn't at -2. It was at -2.54, blah, blah, blah. So I checked it, because this x-intercept really could be like at -0.78. Would I have been surprised by that? Not at all. Could it be to the right of 0? That's how you get like positive 0.137. I don't know. Okay? It would have told me that if it were. Since it didn't give me, since it had an error, it confirms that it's a 0. I don't know why. Okay, there's one more x-intercept, so let's go back one more time. Second calc, 0. See how it gives us left bound? So let's get over there. See it just going right along it. So we're below the x-axis, but we're also to the left of it. Okay, just understand that. It takes some little getting used to reading the graph like that. So that's enter. Let's go above and to the right. Right, I'm above and to the right, enter. And then yes, we would like you to guess, please. And it gives us 3.54. So those are the solutions to this. They're the x-intercepts, they're called the roots, they're called the x-values, they're called a lot of different things. What this means, guys, is you could solve any equation on here. Like, you could take something like 2x plus 1 equals 7, and let's pretend you didn't know how to do it. All you would have to do is get everybody on one side of the equation together. So I'd have to move the 7 over and type it in there and find it 0. I mean, it's a lot more work than solving it, but the 0 is the solution. The 0 is where the graph crosses the x-axis. So make those connections. We're finding it at really high-level polynomials. Okay? Now, part B wants the maxes and the mins. Don't worry about local. Don't worry about any of that stuff. So those are our turning points. And we have 3 turning points. We have 2 mins and 1 max. So, and it doesn't matter which one you find first. Min, we have 2 of those, and we have a max. So I'm just getting ready for them. And part B says just state the x value. And guess what? It's the same exact thing we just did. That's why I'm saying it's going to be like, well, after, I see how fast you guys can text. Once you do this a few times, it's going to be, you can do it faster than I can. So if I want the min or max, I'm going to go back to calc. You might have noticed in that menu, we used 0 before, but there's min and there's max as well. So let's go to 3 or 4, whatever you want to do, and hit min. And so I'm going to go to this min and do my left, right, guess again. So arrow over there. You can hold it down if you want to go really fast. So I'm to the left of the minimum. To the left of it, right? Enter. Go to the right of the minimum. Enter. Guess. Yes. And we should be, we just want the x value, is negative 1.78. And we have another minimum over there. So, second calc, min, left bound. Okay, let's get back over there. And we could have done that one first. I'm just kind of making a point here. It doesn't matter the order they're written in, okay? So I'm to the left of this minimum. Enter. To the right of that minimum. Enter. Yes, yes, please. And we get 2.53. And guys, we already know what this x value is for this max. What is it? 0. Okay. Now, let's do one more. And these are both homework problems, by the way, next Tuesday. So all you'll have to do when we get to Tuesday, you guys will have a lot of this done. So we're getting actual homework problems done here for you. And I'll give you the option of doing 2 more if you want to. But let's do this one. Let's do another one of these. Okay? And we'll save C for next week. This one has something kind of funky going on with it, so I want to do that again. So you can either clear the RAM, but since we really didn't change much in that, and you'll know what I mean by that in a second, I'm just going to go to y equals and hit clear. Or clear the RAM if you want to. But you can just hit clear, and we can just type it in again. So this is the one I messed up on, so be careful. And just so you know, if you get error messages, it's usually because you typed in a minus for a negative. You have to use the negative key for this, okay? That's negative, which is down to the right. 0.25, x to the, and just go ahead on with that. go slow. Make sure you're typing it in correctly. Typing it in correctly.
There we go.
And that would be a minus, not a negative. Okay, so some nitpicky things on these calculators. Minus. So after you type it in, hit graph and make sure yours matches mine. If not, if yours doesn't look like mine, it's because you typed something wrong. Gary, do you have this on your screen? Okay, wonderful. Everybody? Dylan, are you getting these? So you should have this on your screen. You should be fine. This is going to be on your next test. This is on the AP exam. Our test that's coming up in a couple weeks, you have to be able to do this, guys. So you're getting an extra day to practice with it. So don't just be like, I don't want to do it. You have to. Okay? All right. So we're going to find the zeros again. Right? So I can see the zeros. This is what's funky about this graph. Let me just tell you ahead of time in case you start working ahead. The zeros I can see. I can go to the left and the right of my zeros without a problem. That's the process, right? To the left and the right, guess. Left, right, guess. Left, right, guess. That's what we're going to do. But where are my min and my max? This is not, I'm not seeing them. I'm going to have to change this window, which I'm going to show you how to do, to make it so you can't make the window bigger, but we can scrunch it or change the intervals, and I'm going to show you how to do that. So let's take a second right now and find the zeros. There's 3 of them. So by the time you get to the third one, this should be like second nature at this point. You're just going second calc for finding zeros, so that's 2. I'm just going to go all the way to the left. Oh, I know what this problem, I actually got stuck on this one. If you can lose your cursor really easily on this one because the graph is kind of weird. I was uncomfortable with this. In fact, I hit it so fast, it jumped really quick. And here's why. Let me show you guys something else. I'm going to show you how to fix it. So in your table, so if you hit second table, you can see how big these numbers get. At positive 6, it goes to negative 1,418. So that's why we can't see it, okay? So instead of trying to make that cursor visible below and above, left and right of it, let's go right now to changing how we look at it. So go back to your graph, and there's a button across top called Window. Window right here. So hit that. Okay, this is really cool. This is like, you know, when you make your own graph, we normally like go 10 to the right, 10 to the left, 10 up, 10 down, or whatever, and we count by 1. That's what we are looking at right now. It's going to the left 10 and right 10. Scale, X scale, it's counting by 1, 2, 3. And then on the y-axis, it's from negative 10 to 10, counting by 1. We need much bigger. This is where you kind of play with it. There's not a right or wrong way. You can change it as many times as you want. You can keep going back in here. I decided, okay, I can see all my x's, right, all my intercepts. I don't really care about that. Maybe I want to change it later, but I definitely want to see higher and lower on my y-axis. So I'm going to go down, and I just picked a number. I picked negative 50. Would negative 40 work? Would negative 100 work? Probably. There's no right or wrong answer. It's really, you know, you pick a negative and a positive number that you want to try. Maybe don't pick exactly what I have, okay? Pick something around that or not around it. Play with it. And then go to scale, and I'm going to count by 2s. Count by 5. See what happens when you change that. This is time to play. And you can just hit graph. You're not hurting anything. And see if you can see the turning points. If you can, that's all you need. You need to be able to see them. If you can't, go back to window. What happens if I change my scale to 5? So you're counting by 5s on the y-axis. Let's see. Do I like that better? Doesn't really look much different to me. That's why I'm saying it doesn't. There's a lot of different things you can put in there. Okay? But now I can really do my zeros a little bit easier, and I could do my my turning points. So let's just do this. Let's find our zeros. How many zeros are there? How many zeros? 3. It crosses the x-axis in 3 places. 1, 2, 3. Okay? And let's just do this min right here and this max right here. So we're going to have 3x values. Okay, so we're going to have 1, 2, 3, and do the highest turning point and the lowest turning point. Okay? And I'm going to put the answers up for those right now and come around and help you. See if you can get these numbers. Okay? And just pause for 1 second, because I'm going to tell you what you could also do if you wanted to get more homework done, and it's easier than these. Just look with me for a second. If you want to, after you do this, if you want to go do 5 and 7, these are going to be homework problems next week, and all it's asking for is the extrema, which is just min or max. Like this only has a max, right? That's it. It's got 1 turning point. This one has a min, 2 mins, 2 turning points at the bottom, and 1 max. So if you wanted to get 2 more homework problems done today, you could get those 2 done, and that doesn't leave much left for you to have to do next week, okay? So it's good practice while I'm here and able to help you, all right? I'll put the key up to those up in a minute, but right now, this is the key to number 4, okay? So if you are having trouble, this is the time. Okay. So I agree with you. I know this. And 5 and 7, basically for the x and the y, you'll see a different way that it's written. So this, 4. So that's the y value, that's the x value. So it's a fancy way of saying. So either one of those would have been okay. You do, because look what the answers are. They're all decimals. You cannot assume that that's 4.5. You know what I mean? Like on the very first, problem number 1 and problem number 2 on the graph, see how it gives you on 1 and 2, it gives you those points. So you can steal those. You wouldn't need a graphing calculator. Plus, they didn't give us the equation anymore, so we had to read the graph. But on this one, that's written there because we found it. It's not on your graph. Does that make sense? Okay. I didn't feel like I was saying it very clearly. I'm just trying to fit both of these answers on here somehow. One sec. Yeah. Oh, okay. Yeah. But this is not homework. That's the second one. You can look when I set up this right now. I will teach the lesson actually today. Yeah, it's what you review. So this is a, like, there's a lot of points about power, right? But in our view area, they're relative to what we're looking at, that is a not. So all training points are something. So relative minimum, absolute minimum. No, absolute minimum. And what's crazy is we also call absolute non-equal relative.
I'm a little confused when I'm supposed to be doing the same thing.
I look at the direction, this time you repair them.
Oh,
Yeah, see, I have the key up here for you too. You just don't, so the way I set it up was just max, right? This is a max. Then you have 2 mins and a max. So just you're naming your turning points, okay? And in the first ones we did, they just wanted the x values, okay? So we used the x values. Here they're naming them kind of 2 different ways. This is the y value right here. That's the x value. So it's like there's an absolute max at 4.5 or the absolute max is 4.5. Where does it happen? At x equals -3. It's just a fancy way of saying that. She'll see it all different ways. Okay? And I'll explain again on Tuesday, but really I wanted you guys to have good practice with the calculator. I know. You're going to be happy on Tuesday. After a long weekend, you're going to be like, oh, I already know how to put